We're going to have a look at the converse of Pythagoras. Now, we've looked at Pythagoras' theorem, and we know that Pythagoras' theorem is used in right-angled triangles to find the length of a missing side if we know the other two sides. Now, the converse of Pythagoras' theorem, think about the meaning of the words. Converse means the opposite of. So the converse of Pythagoras' theorem shows whether or not any triangle is right-angled. Okay. Now, very fussy about the way you set out your working for converse of Pythagoras' theorem. You cannot assume that the triangle is right angled, so you cannot use Pythagoras' theorem in its entirety. Okay, so watch the way I set out the working for this. Okay. First example then, we want to decide whether or not this triangle is right angled. Now, if it was to be right angled, we'd look at the right angle being in there, because opposite the right angle is always the longest side, and 5 is the biggest number there. Okay, so that would be my longest side. So the first thing I want to do is square my longest side. So I get 5 squared is 25. And then want to square and add my other two sides. So 3 squared add 4 squared is 9 plus 16, which is 25. Now they're the same thing. Okay, so since they're the same, so we can say since 3 squared plus 4 squared is equal to 5 squared. So that's since the square of the shorter two sides is equal to the square of the longest side. That means it is right angled, because that means I could use Pythagoras and I would find that third side. So since 3 squared plus 4 squared is equal to 5 squared, by the converse of Pythagoras' theorem, the triangle is right angled. Here we'll try a second one. Triangle again. There's my longest side, so I'm trying to decide whether or not this angle here is a right angle. So again, start with my longest side. So 12.8 squared is 163.84. Square and add the shorter two sides. I'm doing 10.2 squared plus 7.6 squared. That would be 161.8. This time they're not the same, they're not equal. That means it's not a right angled triangle. So we say since 12.8 squared is not equal, so it's an equal sign just with a line through it, so it's not equal to 10.2 squared plus 7.6 squared, by the converse of Pythagoras' theorem, the triangle is not right angled. The two sides are quite close. Okay, there's not far between 161.8 and 163.84, but they need to be exact. It needs to be exactly the same. The closer the angle is to 90 degrees, the closer that the answer will give you to being the same. But it could be 89 degrees or 91 degrees. It needs to be exactly 90 degrees to be a right angle. So they need to be exactly the same. I'll show you an exam type question with this. I'll just move this down a wee bit. Right, so we've got triangles A and B, and the triangles are placed together to form this larger triangle down here, and we want to know, is this larger triangle right angled? So let's put some sizes on this triangle here. So the length of this side here has come from here, so that will be 8 centimetres. This bit here will be 19, and down the bottom we've got 6 and 16, which would be 22 centimetres. Now my right angle I'm looking for would be this part here. Start with my longest side, and I square it. I get 484. Square and add my other two sides. Do 19 squared plus 8 squared. Which is 425. Now they're not the same, they're not equal, so we're going to say 19 squared plus 8 squared is not equal to 22 squared. So by the converse of Pythagoras' theorem, the triangle is not right angled. Okay, now let's practice some of these.